Opening scene. Haunting, ambient music begins. The screen is black. Narrator. Have you ever stood beneath a canopy of stars, truly stood there, and felt an overwhelming sense of smallness? A profound, humbling awe that quiets the noise of daily life. It's a primal feeling that has connected humanity for millennia, from our earliest ancestors to modern-day astronomers. In that silent, upward gaze, two fundamental questions echo through the chambers of our minds, questions that form the very bedrock of our quest for knowledge. The first is directed outward. What is all this? This cosmic ocean of galaxies, the invisible fabric of space-time, the beginning, the end, and the mind-boggling scale of it all. And the second, perhaps more bewildering question, turns inward. It's the voice that asks, who am I? What is this spark of awareness peering out from behind our eyes? What is this consciousness that can feel awe, ponder its own existence, and even conceive of the universe's origins? This is the central paradox of our existence. We are composed of ancient stardust, governed by physical laws, yet we are also the universe's only known way of knowing itself. We are both the spectator and the spectacle. These are not just idle philosophical musings. They are, as physicist Michio Kaku calls them, the two greatest mysteries in all of science: the mystery of the cosmos and the mystery of consciousness. One is the puzzle of the infinitely large, of dark matter, black holes, and the origins of time. The other is the enigma of the 3-pound universe inside our skulls, the source of thought, feeling, and self-awareness. They are the final frontiers. In this series, we will journey to the very edge of what we know, to confront these ultimate questions. Music shifts, becoming more dynamic and anticipatory. Our journey begins where it all began, nearly 13.8 billion years ago. Before stars, before galaxies, before even space and time as we know them. Our entire observable universe, every planet, every sun, every one of the 2 trillion galaxies we now estimate exist, was compressed into a singularity, a point of infinite density and heat smaller than a single atom. Then, in an instant that defies all earthly comparison, it erupted. This was not an explosion in space, it was the explosion of space itself, the Big Bang. From that singular explosive event, reality began to unfurl. The fundamental forces of nature, gravity, electromagnetism, crystallized into being. Within minutes, the first atomic nuclei were forged in a crucible of unimaginable temperatures. It took another 380,000 years for the universe to cool enough for light to travel freely, an afterglow we can still detect today as the cosmic microwave background. It's a story written in the language of mathematics, first imagined in the minds of pioneers like Albert Einstein, and now witnessed through the powerful eyes of our greatest telescopes. We are seeing not just light, but time itself. But this breathtaking picture is profoundly incomplete. As our map of the cosmos has grown, so have the vast uncharted territories. We have learned that everything we can see, the stars, the galaxies, us, makes up a mere 5% of the universe. The rest is a combination of mysterious, invisible substances we call dark matter and dark energy. What is this cosmic phantom that holds galaxies together? And what happened before the Big Bang? For every answer, a dozen new, more mind-bending questions arise. And that is where the real adventure begins. Music swells and fades, leaving a sense of mystery. It fades in with a low, inquisitive, and slightly ominous tone. Narrator. The adventure begins not in the light, but in the shadows. To understand this cosmic phantom, we first had to learn to see the invisible. Consider a spiral galaxy, a magnificent celestial pinwheel containing hundreds of billions of stars, all held in a delicate gravitational dance. According to everything we know about gravity, the laws laid down by Newton and refined by Einstein, the stars on the outer edge of this pinwheel should be moving much slower than the stars near the bright, dense center, just as Neptune, at the edge of our solar system, plods along while Mercury zips around the sun. But they don't. When astronomers, led by the pioneering work of Vera Rubin in the 1970s, pointed their instruments at these outer edges, they found something that defied all logic. The outer stars were moving at incredible, breakneck speeds. So fast, in fact, that the gravity from all the visible matter, all the stars, gas, and dust, shouldn't be nearly strong enough to hold on. The galaxy should have torn itself apart eons ago, flinging its stars into the empty void like water from a spinning tire. The only viable explanation was as bold as it was unsettling. There must be something else there, a vast, invisible halo of mass surrounding the entire galaxy, providing the extra gravitational glue needed to hold it all together. We can't see it. We can't touch it. It doesn't appear to interact with light in any way. We only know it's there by the way it relentlessly pulls on everything we can see. This is dark matter. It's not just in the gaps between the stars. It is the very scaffold upon our luminous universe. It outweighs all the normal matter we know, all the atoms in the cosmos, by more than 5 to 1. But as physicists grappled with this invisible substance holding the universe together, they stumbled upon an even more profound mystery, a force doing the exact opposite. In the late 1990s, 2 teams of astronomers were using distant exploding stars, supernova, as cosmic lighthouses to measure the expansion of the universe. They fully expected to see the expansion slowing down, pulled back by the immense gravity of all the matter, dark or otherwise. Instead, they found the impossible. The expansion wasn't slowing down, it was speeding up. Something is actively pushing space itself apart, a kind of anti-gravity woven into the very fabric of the cosmos. We call it dark energy. It is the single biggest component of the universe, making up nearly 70% of everything that exists. It is the universe's dominant force, and its discovery was so shocking, its existence so bizarre, that it has thrown cosmology into a state of beautiful, exhilarating chaos. So, this is our modern map of reality. 5% is the stuff of us, of stars, planets, and nebulae. 27% is the invisible dark matter, the cosmic skeleton. And a colossal 68% is the dark energy, the mysterious force pushing it all apart at an ever-increasing rate. We live in a cosmos whose fundamental nature and ultimate fate are dictated by 2 phantoms we have only just begun to chase. We are, in a very real sense, strangers in our own universe. Music holds on a single, resonant, mysterious note before fading. This. Music fades in with a low, inquisitive, and slightly ominous tone. Narrator. The adventure begins not in the light, but in the shadows. To understand this cosmic phantom, we first had to learn to see the invisible. Consider a spiral galaxy, a magnificent celestial pinwheel containing hundreds of billions of stars, all held in a delicate gravitational dance. According to everything we know about gravity, the laws laid down by Newton and refined by Einstein, the stars on the outer edge of this pinwheel should be moving much slower than the stars near the bright, dense center, just as Neptune, at the edge of our solar system, plods along while Mercury zips around the sun. But they don't. When astronomers, led by the pioneering work of Vera Rubin in the 1970s, pointed their instruments at these outer edges, they found something that defied all logic. The outer stars were moving at incredible breakneck speeds. So fast, in fact, that the gravity from all the visible matter, all the stars, gas, and dust, shouldn't be nearly strong enough to hold on. The galaxy should have torn itself apart eons ago, flinging its stars into the empty void like water from a spinning tire. The only viable explanation was as bold as it was unsettling. There must be something else there, a vast invisible halo of mass surrounding the entire galaxy, providing the extra gravitational glue needed to hold it all together. We can't see it. We can't touch it. It doesn't appear to interact with light in any way. We only know it's there by the way it relentlessly pulls on everything we can see. This is dark matter. It's not just in the gaps between the stars. It is the very scaffold upon our luminous universe. It outweighs all the normal matter we know, all the atoms in the cosmos, by more than 5 to 1. But as physicists grappled with this invisible substance holding the universe together, time, and found a beginning shrouded in enigma. We have mapped the heavens and discovered that 95% of the map is blank, labeled only with the placeholders dark matter and dark energy. Our grandest theories, the twin pillars of modern physics, crumble when faced with the immense void of space or the infinite density of a black hole. It seems the more we learn about the cosmos, the more it confounds us. But what if the greatest abyss in our understanding isn't in the vast emptiness between galaxies? What if it's in the 6 inches between our ears? We now turn our gaze from the outer cosmos to the inner one. We pivot from the first great mystery, the universe, to confront the second and arguably the more profound, consciousness. This is the miracle of awareness, the simple yet inexplicable fact that you are not just a collection of atoms. You are experiencing these words. You are having a subjective, private, internal life. You know what it feels like to see the color blue, to smell rain on hot asphalt, to feel the sting of sadness or the warmth of joy. From a purely physical standpoint, the brain is the most complex object we've found in the universe. A 3-pound lump of tissue containing nearly 100 billion neurons, each connected to thousands of others, forming a network with more potential connections than there are atoms in the known universe. It is a biological supercomputer, firing off trillions of electrical signals every moment, processing information at a staggering rate. We can track these signals. We can see which parts of the brain light up when we look at a face, listen to music, or make a decision. This is the easy problem, mapping the physical processes, the neural correlates of consciousness. But it doesn't touch the hard problem, the deep central question: why? Why should all this frenetic electrochemical activity feel like anything at all? Where, in this intricate dance of ions and neurotransmitters, is the taste of chocolate? Where is the feeling of awe you felt when you first looked up at the stars? There is nothing in the equations of physics that predicts a collection of carbon atoms should be able to ponder its own existence. This is the great explanatory gap. We can describe the hardware of the brain in exquisite detail, but we have no idea how it generates the software of the mind. Is consciousness simply an illusion, a clever trick our brain plays on itself? Is it an emergent property of complexity, something that just switches on when a network reaches a certain level of sophistication? Or could it be something even more fundamental, woven into the fabric of reality itself, just like space and time? This mystery challenges the very foundations of science. It forces us to ask whether our current understanding of the physical world is even capable of providing an answer. To solve the riddle of the mind, we may have to rethink reality one more time. Music shifts, becoming more questioning and building anticipation for the next part. Music fades in, more complex and layered than before, a fusion of organic and synthetic sounds, reflecting the biological and computational theories of mind. Narrator: to solve a mystery of this magnitude, to bridge the chasm between the brain's gray matter and the mind's technicolor experience, requires a radical departure from conventional thinking. Science, once a discipline of the observable and the external, must now turn its tools inward to confront the nature of the observer. In this new frontier, thinkers are armed not with telescopes, but with audacious theories, each offering a startlingly different vision of who we are. The most conservative view, held by many neuroscientists, is that consciousness is an emergent property. It's what happens when simple components, in this case neurons, organize themselves into a system of staggering complexity. A single neuron isn't conscious, 1,000 aren't, but 100 billion, wired together in a specific architecture, cross a critical threshold and the lights of awareness simply switch on. In this view, consciousness is a symphony played by the orchestra of the brain. You can't find the symphony by examining a single violin, yet it undeniably exists when they all play together. It's a compelling, elegant idea, but it still struggles to explain why this specific symphony should feel like anything at all. It describes the conditions for consciousness, but not the experience itself. Another approach reframes the question. Instead of complexity, perhaps the key is information. Proponents of integrated information theory, or IIT, suggest that consciousness is integrated information. Any system, whether biological or artificial, that can take in vast amounts of information and weave it into a single unified whole possesses some degree of consciousness. Your brain does this at an unparalleled level, binding sensory inputs, memories, and thoughts into one seamless ongoing moment of experience. IIT offers a mathematical framework to measure this integration, and it comes with a radical implication. Consciousness isn't an all-or-nothing affair exclusive to humans. It's a spectrum. A mouse, a bee, even a thermostat could possess a tiny, faint glimmer of it. But where does the information itself get its subjective quality? This leads us to the very edge of physics and a far more provocative idea. What if the brain isn't a classical computer at all, but a quantum one? Some physicists and philosophers argue that the mysterious rules of the quantum world are not confined to the subatomic realm. They propose that these processes may be happening within the delicate microscopic structures of our own neurons. In this view, our consciousness isn't computing answers, it's collapsing quantum possibilities into a single classical reality with every thought. This would mean our minds are intimately connected to the fundamental weirdness of the cosmos. Yet the most mind-bending theory of all flips the entire problem on its head. What if consciousness isn't something the brain produces at all? What if, like gravity or charge, it is a fundamental, irreducible property of the universe itself? This is the ancient idea of panpsychism, reborn in modern philosophy. In this view, every particle in existence possesses a minute, primitive form of consciousness. For the most part, it's disorganized and simple, like the consciousness of a rock. But when these particles are organized in the complex structure of a brain, these tiny streams of awareness combine to form the powerful high-definition river of consciousness that is you. We are not a brief flicker of awareness in a dead universe. We are the universe becoming intensely aware of itself. From an illusion of complexity, to a quantum phenomenon, to a fundamental force of nature, these are the battle lines in the search for the self. Each theory pushes the boundaries of what we dare to imagine, and each one forces us to reevaluate our place in the cosmos, setting the stage for one final unifying question. Music swells, a grand orchestral theme that feels both cosmic and deeply human, carrying echoes of the series' main melody. Narrator: we have journeyed to the edge of space and the center of the self. We have chased cosmic phantoms through the void and pursued the ghost of consciousness through the labyrinth of the brain. And now we arrive at the final unifying question, the one that loops our two great mysteries into one. Why does the universe seem so exquisitely built to be understood? Why is it comprehensible at all? Consider the fundamental constants of nature, the strength of gravity, the charge of an electron, the energy density of empty space that we call dark energy. Physicists have discovered that these values are balanced on a razor's edge. If any of them were altered by the slightest fraction, the universe as we know it could not exist. Stars would not form, atoms would not be stable, carbon-based life, and therefore consciousness, would be an impossibility. Is this just a colossal coincidence? Are we simply the winners of a cosmic lottery on a scale we can't imagine? Or does it hint at something deeper? This is the anthropic principle, the idea that the universe must, in some way, be compatible with the conscious life that observes it. This leads to a staggering thought, one that teeters on the edge of science and philosophy. Perhaps the universe is the way it is because we are here to see it. This idea finds a strange echo in the bizarre rules of quantum mechanics. At its most fundamental level, reality seems to exist in a ghostly fog of possibilities until it is measured or observed. The very act of looking appears to force the universe to pick a state. What does it mean for reality to depend on an observer? Some bold thinkers, like the legendary physicist John Wheeler, proposed that we live in a participatory universe. That by observing the cosmos, from the Big Bang's afterglow to the present day, consciousness is not just a passive spectator, it is an active participant, transforming the quantum haze of potential into the concrete reality we inhabit. In this mind-bending vision, the two great mysteries collapse into one. The universe gives birth to consciousness, and consciousness, in turn, helps give reality to the universe. We are not an accident. We are the mechanism by which the cosmos becomes real to itself. The stardust has not only woken up, it has become the co-author of the story. The observer and the observed are locked in a timeless, creative dance. So we stand once again beneath that canopy of stars. The smallness we feel is not one of insignificance, but of profound connection. The awe is not just for the scale of the cosmos, but for the astonishing fact that a mind exists to comprehend it. The answers to our ultimate questions may not lie solely in bigger telescopes.
The world is full of fascinating paradoxes, isn't it? We hope today's facts truly bent your mind. If you're ready for more daily revelations that challenge the norm, subscribe to Mindbenders. Don't forget to ring the bell so you never miss a new video. Until next time.